Okay, let's go over this practice quiz. You need to make sure the entire packet is complete and that you understand all these problems. So this next quiz should be pretty easy. You're going to definitely see a section where I want you to take a true statement and rewrite it in logarithmic form. Okay, so when you write it as a log, you need to realize its base is 16. So we're going to do log base 16 of 4. And remember, logs are the exponents. Okay, so log base 16 of 4 is equal to 1/2. And you can prove that on a calculator. So if you would type in the math key, base 16 of 4, 16 needs to be raised to 1/2. It's basically a square root of 16 is a 4. This one, base is 7. It's a 49. And the answer is 2 because 7 squared is 49. Okay, here my base is once again 16, but it's going to be 1/2. And it equals negative 1/4. Okay, so again, always make sure logs are equal to the exponent. So I know it's going to be equal to negative 6, this last problem. So it's going to be the log of your base, or so log base 2 of 64 equals negative 6. Okay, now going in the other direction, I now want you to write this in exponential form. Again, a true statement. So my base is 12, the exponent is negative 2, and the fact is 12 raised to negative 2 is 1 over 144. Okay, it's 1 over 2, or 12 squared, which is 1 over 44. For this one, my base is 121. If I raise that to the 1/2 power, it's basically the square root of 121, which is an 11. Okay, so again, long as you put the numbers in the proper spot, you'll get a true statement. Here we have 3 as my base, my exponent is 2, and the fact is 3 squared equals 9. Base is 16, we raise it to the negative 1/2 power, and it's going to equal 1/4. Okay, so again, if you're not sure, take 2 seconds on your test to just make sure your statement is true. Okay, 16 raised to the negative 1/2, this will tell me 0.25, which is 1/4. Okay, I know I did it correctly. Okay, this next section you are going to expand. So for number 9, I see 1, 2, 3, 4 things. Okay, so I'm going to need log base 2 4 times. Okay, so this is really being expanded out. So we can save a step. So the first thing we see is the a to the 6, but I'm going to put the 6 out front. Okay. Now notice how everything else is in the bottom. So we need minus signs separating all this. So the first thing we see is just a 3. So log base 2 of 3. Okay. Next thing we see is this b, but b is being raised to the 4th power. So I'm going to have a minus 4 there. Okay, treat this as a negative 4 as your exponent, b to negative 4. It would end up in the denominator as a positive. Okay, so remember what negative exponents are. And then the last thing, it's going to be a minus c squared, but I'll put the 2, the exponent goes in front of the log, and then we have a c. Okay, there's your answer. Okay, the next one I only need log 3 times. So I have a 12, I have a u, and I have a v to 6. So log base 6, log base 6, log base 6. Okay, first thing we see is just a number 12. So it's log base 6 of 12. Since we're multiplying, I'm just going to have a plus sign. And then the next thing we see is just a u to the 1st power, so I don't need a number in front. It's understood to be a 1. And then the last thing is v to 6. I'll put a 6 in front, a positive 6, and then the letter v. We're done with that. Okay, that's expanding. Now condensing, I think, is easier. You're just writing it as a single log. Okay, since I see a minus sign, I know I'm going to have a division problem. I know it's going to be a quotient. But the first thing we see is up top. It's a z. The second thing we see, since it's a plus sign, it's going to stay up top. It's going to be x squared. Remember, this 2 becomes the exponent. So x squared. And then in the bottom, so that y is in the bottom, but then it's going to be to the positive 2. Okay, and we're done. This last problem here on this front page, it's a single log. Now notice I don't see any negative signs, so it's not going to be a quotient. So I just need to multiply everything. So I'm going to have an A, then I'm going to have B to the 7th power. So this 7 is the exponent for the B. And then I'm going to have the letter D. And then I'm finally going to have the letter C, but to the 3rd power. Okay, do not make this any harder. Okay, just apply those properties and you're going to be in good shape. The next part of this practice and what's going to be on your test, you'll have a quick section like this in your test, and you can rely on the calculator. Okay, so you can hit the math key and you can find log base, put your base, put the number, and hit enter. And some of these will be a nice answer, some will be a decimal. So if it's a decimal, I tell you to round to 3 decimal places. So this next one's going to be a decimal. So math, scroll up, log base, the base is 5, the number is 216, and we're going to get 3.3, and I'm going to round. This would become a 0, that's going to become a 4, so 40. Okay. Now I could have a calculator. If you hit mode, you can turn your float to 3, and then it will automatically round the 3 decimal places. But if you don't like that, turn the float off. Okay, so just highlight float or reset your calculator. Okay, now this one, I know is going to be a -2. Okay, I know 7 needs to be raised, but again, you can check on a calculator just to double check. So if I have a base of 7 and it's going to be 1/49, I feel good about my answer of -2. Okay, so this I know is going to be a -3. So it's math, log base, put in your base of 1/3 and put in a 27, 27, and it's going to tell me -3. Okay, so if you can do them in your head, just write down the answer. If you can't do it in your head, use your calculator. Now, I also showed you that change of base formula. So if you wanted to, you can do the common log of the number, close the parentheses, and the common log of the base. So another way of getting this correct answer is 3.930. Okay, so it's the exact same thing as hitting the math key and then putting in a 3 and a 75. You get the exact same answer, but you can always do the common log of the number divided by the common log of the base bottom. Okay, so for this one, I'll use the common log. I'll do the log of 549, 9. Close the parentheses, though. You need to close the parentheses or hit enter, then divide by the common log of the base. And so we get 3.24, and I'll round that 1 to a 2. There you go. Super easy. I need you to make sense of that. And then for this goes back to section 6.1, where we have an exponential function, and I know it's growth because my base is greater than 1. So when I ask growth or decay, I know it's growth. Okay, it's going to curve up. Okay, so from there, we can just go to the y equals screen. 3 raised to the x minus 2, and then a plus 1. So I know it's a shift up 1, and we're actually shifting to the right 2. So when we hit graph, we're going to see that it's shifted over. Okay, so it's actually shifted over to the right 2. So when you go to your table, we're just going to find a couple nice dots. So the best dot I can plot is, let's go with 2, 2. So when x is 2, we're up here at 2. We'll do 3, 4. So 3 up 4. And then we'll do 4, 10. 4 all the way up to 10. And then what you need to realize is, since you're shifting up, we need to stay above 1. We will never actually get 1. So if you want to, you can do a dotted line. Okay, dotted line, and just stay above that. Okay, stay above the dotted line. And then just realize your domain, we said this when we went over this in our notes, is all reals. Okay, you can raise a base to any number, decimals, fractions, negatives, doesn't matter. So every number you can replace the input with. But as far as your outcomes, your range, since we shifted up one, its y values have to be greater than 1, not equal to 1. Okay, so technically we're always going to have, since we're having a number, this will always result in a number greater than 0, and anything plus 1, it's going to be above a 1. Okay, so 1 over a million plus 1 is still more than a 1. Okay, so just make sure you're aware of the domain and range of exponential functions. For this part, we have a word problem, and instantly, the second I can see the base, I know it's going to be a decay problem, okay? Because the base is less than 1. So does this represent a growth or decay? I know it's decay. The base is less than 1, okay? So now, how much less than 1? So be careful of this question. By what percent is the population increasing or decreasing? I know it's decreasing, and I know it's decreasing by 12%. You say, how in the world did I do that? 1 minus your base, okay? It's a difference of 0.12, which is 12%, okay? So you need to figure out what's the difference between your base. Now, if it was greater than 1, then it would be a growth by whatever the difference is, okay? So now, this is where you would just go to your y equals screen, type in this rule. So we're really starting out with 123,000 people, okay? And then just make sure you either put it in parentheses or hit times 0.88. Okay, you got to have something there. It's not this 0.88, so it's times this raised to the x power, where x stands for years. So I'm going to have my table start at 0. And this is our starting point. We started out with 123,000, and then each year the population is decreasing, okay? So what I'm asking you to do is find 10,000, okay, or close to 10,000 as possible, and you can see it occurs when x is 19. So you just understand that this is years since 2000. So sometime in between 19 and 20, so you can say in the year 2019, that's when we would reach a population of 10,000. Okay, by 2020, we're at 9,540. So it occurred in the year 2019. Okay, and then I just want you to go to 22, and then you can see in the year 22 years later, so when x is 22, we had 7,386.9. And again, if it's people, population, you could round. 7,388 would be a better answer. Okay, so we're just estimating the population in the year 2022. Okay, so then this next problem, you're guaranteed to see this. I will tell you how much money we're taking to a bank. So I would want you to write this. I just need to see what you typed in your calculator. So show this, use this formula. My P is the principal. My rate, you must put 0.0425. Okay, move this decimal point 2 places to the left. If you mess this up, you only move it 1 place or you forget to move it at all, you're going to get an outrageous answer. Okay, but we are compounding monthly. So as soon as you see monthly, you need to know that n is 12. If you see daily, n is 365. If you see quarterly, it's 4. Okay, so look at your notes. And then I have to divide by 12. And we're going to keep this in the bank for 12 years, but don't forget to multiply by 12. So in those 12 years, it's going to be compounded 144 times. So then all you need to do, go to your blank screen on your calculator and type this in, exactly how we have it on paper. So I'll do it this way so you can see. There we go. So 5,500 is our starting amount. We have parentheses 1 plus 0.0425. We need to divide that rate by 12. Then we need to raise to 12 times 12. Okay. So at the end of 12 years, your $5,500 really becomes $9,150.85. Okay, so not bad, not bad. And then these last two problems on this part of the review, I wanted to review because a lot of people on their Chapter 5 exam, you didn't understand that you can't distribute, okay? PEMDAS, this exponent is preventing us to distribute the 2. If that power wasn't there, then I agree, you can multiply by 2, okay? But since we have a power, we must undo multiplication by dividing. That must be your first move here. Get rid of outside numbers. So now I have a plus 8 raised to the 3/2 power, and this equals 8, okay? We learned in Chapter 5 to undo, because you can't, expand this out. You want to undo an exponent by raising to its reciprocal. Okay, so we're simply going to raise to its reciprocal. That gets rid of the power. It turns it into a power 1, which is just a plus 8. And I'm just going to ask the calculator, hey, calculator, what's 8 raised to the 2/3 power? And it's going to tell you 4. And then I only have one last move, and I know my answer is -4. Okay? So then this last problem, and we'll do the second part of this. You want to undo these two. So what's being raised to a power is just the v, okay? So the first move, I must add a 4. So I must keep the 2v raised to the 3/2 power, and it's going to be 1458. But now I don't get rid of the power yet, because now if I had parentheses around this, then I would get rid of the power. But since there's no parentheses, I must undo the 2 in front by dividing by 2. Okay, so 1458 divided by 2 is going to be 729. And now my last move is to raise this, both sides, to the 2/3. And the calculator can tell me what 729 raised to the 2/3 is. And it's going to tell me a nice 81. Okay, so that's part 1. We still have to do part 2, but that took 17 minutes. Your quiz should not take more than 20 minutes to be able to complete. Okay, we have to do part 2 yet. So part 2 is just more practice, same type of problems you're going to see on your quiz. So we're rewriting this in logarithmic form. It's log, here's my base of 1/19. The number is 1/361, and that would equal 2. Remember, logs are exponents, okay? Here, it's base 20 of 400, and it equals 2. And remember, you could check that on a calculator. You type that in, you better get a true statement. So, fact is, 20 squared is 400, okay? Here, log base 3 of 81, that would be an answer of 4. Okay, so again, just rewrite. We should be able to go from one form to the other. So here, we're going to rewrite this in exponential form. My base is 9. If you raise it to the -2, you would get 1/81. Here, if you take 18 and raise it to the second, you will get 324. Okay, so I'm going to give you a true statement, and you write a true statement. 4 squared equals 16. Okay, so again, that should be very quick on the quiz. Make sure you don't mix up the numbers. Okay, here we're just evaluating. Again, you can use your calculator. Here I know, I'm not going to use a calculator for this one. I know 7 squared is 49. Okay, I also know that 3 cubed is 27. Okay, so, but again, just a reminder, you can hit the math key, scroll up. Scroll up to log base, and then put your little 3, put your 27, and it's going to tell you 3. Okay? This next page, I know this is going to be a -2. Okay? These are ones that I can do in my head. I know this is going to be also -2. Okay? Now, watch this. So if I do math key, scroll up, and I go 8, and then of 0, 8 raised to what power is going to make it a 0? You're going to see it's impossible. No answer. It's undefined. Undefined. Okay? So you remember, you get an error in the calculator, which means it's impossible to find. 8 cannot be raised to anything to make it 0. You can get real close to 0, it's just not going to be 0. Okay? And then this one, here I'll use that in case you have a calculator, just a log key. Remember, if we just have a log key on a calculator, you can always take the common log of the number divided by the common log of the base. So you'll see it's a 3. Okay, 6 cubed is 216. Okay, should make sense. Here we have a graph. We already know that the domain is going to be all reals. Okay, so, and then the second we see this base, we know it's decay. It's less than 1. Okay, so state if it's growth or decay, we know it is a decay. Okay, so then I also know, once again, since we have a -2 next to the x, is going to be shifted to the right 2 and up 2. So I'm going to draw a little dotted line here because I know I'm never going to cross that. I'm never going to touch an outcome of 2. Okay, so I can actually say the domain before I even look at the graph, but it always helps to see the graph, then state the domain. Okay, but I know the domain is all reals, and I know my range is going to be y values greater than 2, not equal to 2. Okay, and we're going to see that when we type this in the calculator. So if I go to the y equals screen, I'm going to type in my base, which is less than 1, so it's a decay, raised to the x minus 2, and then I'm going to have a plus 2. Okay, I can see what the graph looks like. It's going to go like this. Okay, it's coming down, and then I just go to my table, and I'm going to see my table all the way there. So it's good. The calculator does say eventually it says 2, but it's not equal to 2, okay, because calculator just runs out of decimal places. So we have 0, 11. So I'll put a dot right there, okay. -1 all the way up to 29 would be all far, but I can start with 0, 11. I can do 1, 5. So 1 up 5 blocks, and we can do 2, 3. Okay, and just make sure when you connect this, make your curve. Okay, so it curves down very quickly. Draw an arrow up, because eventually it's going to get really large numbers as your x values are getting smaller. The y values get really large, and then here, as x gets larger, you're getting closer and closer to an outcome of 2. So even when the calculator says 2, again, it runs out of room. It's really not 2. It's always going to be above 2. Okay, so just keep that in mind when it comes to graphing exponential functions. Okay, almost done. Last page. So I give you another problem where, once again, we can see its decay. So I know instantly that it's decreasing over time. So here we have a population. What is this? It's 90,000. Okay, I'm making up these numbers. 90,000, you can see the base is less than 1, so we know, once again, it's a decay. Now, maybe on your test, it'll be a growth, okay? So maybe this will be 1 point something. So then you know it would be growing over time. So by what percent is the population increasing or decreasing? Well, the difference between 1 and my base is going to be 0.06, which you need to understand is a 6%. So it's a 6% decrease. Okay, that should make sense to you. Not a 94% decrease. It's the difference between the base and 1. Okay? In what year? So to be able to tell this, we need to go to our calculator once again and just type in this rule. Type in the 900,000, 1, 2, 3, and then my base, which is 0.94. I need to raise it to the x. So I'm going to have my table once again start at 0, so that when I go to my table, I can see there's our starting amount. We had 900,000 people in the year 2000. As time goes by, you're seeing the population decrease. So we're going to keep on going until we can get close to 470,000. Okay, so we can see in the year 2010, we start out, so like in January, we have 484,754, but within that year, we're going to be at 470,000. So you're just going to need to say in 2010. Okay? And then to answer the question of 22, I guess I should update this to 25 since we're in the year 2025 now, but you just have to go to 22. So this represents the year 2022. We have 230,704 people. Okay? So again, easy application, but on your test, you'll see something very similar, but we could be dealing with home prices, or we could be dealing with some other aspect, and you should instantly be able to tell if it's growth or decay. Use your table and your calculator to actually find the answer. Okay? Here's another one where I'm going to give you that formula where I will tell you how much money, so all I can do is change the amount of money we go to the bank. So your ending amount, what we're trying to find, we start out with $7,500. We're taking this to the bank. The formula is 1 plus my rate as a decimal. So in this case, 0.055. We are going to do it weekly. So you need to know that there are 52 weeks in a year. So we're going to divide the rate by 52. And you're going to raise it to the number of years times n. And like I said, in this case, we have 52 weeks in a year. Okay, so then all I have to do is type that into my calculator. So go to your blank screen. Here's my blank screen. 7,500 parentheses 1 plus my interest rate divided by 52, close the parentheses, raised to the number of years, times n, which in this case is 52, and round to the nearest penny. So you would have $14,505.88 at the end of that 12-year period. Okay, so again, should be impossible to mess that up. Okay, it's not, people say, I struggle with word problems. Well, it's a straightforward word problem where you should know exactly where to substitute in and then just use your calculator. You're really not solving for anything, you're just calculating. Okay, so then I have two more equations from chapter 5, so I always want you to remember what we did in chapter 5. So for 19, I have this whole quantity raised. There's no numbers on the outside, so I don't have to undo numbers on the outside, so I'm ready to undo this exponent. So to undo an exponent, we raise it to its reciprocal. Okay, so I know it's going to be x plus 16 equals whatever 243 raised to the 3/5. Okay, and make sure you actually raise it. You can't divide. Okay, so I need you to understand what we're doing here. And the calculator tells us it's a 27. And now it's easy to solve for x. I just take 27 minus 16. It's going to be an 11. And there it is. Okay? So then this last problem, I cannot raise. So unlike this problem where my first move was to get rid of the exponent, my first move cannot be to raise to 2/3. Okay, and the reason is there's a 5 here, and it's not in parentheses. Now, if this was in parentheses, then my first move would be to raise to the 2/3. But since that 5 is not with that 5 is not being raised to a power, I'm going to undo it by dividing. Okay, so I'm just going to take my calculator, 1715 divided by 5, and we're going to get 343. And now I can get rid of the exponent by raising to the 2/3. Okay, so we just raise this to the 2/3, and you're going to see your answer is 49. Okay, so this last problem, we would have to do, this would be considered a bonus. So I'm just going to preview where we're heading. Okay, so this, I just want you to get the answer for. You can use your calculator, but since I want it to 3 decimal places, you would really have to drill in your table to be able to find this answer. But here's what I want you to understand. We are, in a couple days from now, after we take our quiz, we're going to learn actually how to solve an equation where I want to know, when will we have exactly 18,000? I want to have $18,000 that I can get from this bank, but we're only taking $5,000, okay? We have 1 plus my interest rate of 0.075. We're compounding quarterly, so we divide by 4. And we don't know how many. We don't know how many years, okay? So we want to know how many years will it take, and we don't want it to be a whole number. We want it to be exactly, okay? So we don't know what t is, but we do know we need to multiply it by 4. So really 4t, okay, or t4. That's what we're solving for. So we need to undo things so that we can solve for this exponent. So right now, you don't know how to solve for an exponent, but I'm going to teach you right now, and it'll just be a preview of where we're going. So just like with solving these equations, 19 and 20, I need to undo that 5 that you cannot distribute, okay? Order of operations, this is being raised to a power, so I'm not allowed to distribute. So instead of distributing, I'm just going to divide. So if I divide by 5,000, take your calculator, type in 18,000. That's what we want, divided by what we started with, the 5,000, you're going to see it's 3.6. So really, we want to multiply our money by 3.6. Okay, so now we have this base. Now, I'm actually going to write this base as a decimal. So I'm going to ask the calculator, hey, calculator, what's 1 plus 0.075 divided by 4? And it's going to tell me, whoops, why did I get an error? Let's try that again. So it's 1 plus 0.075 divided by 4. And we get 1.01875. Okay, and I'm just going to leave that. Okay, don't round that. You don't want to round that number. I want to have an accurate answer. Okay, so here's the whole point. We are going to learn this. Whatever the base is, we're going to use the log of that base. Okay, so I'm going to rewrite this. Remember how we rewrote from exponential form to logarithmic form? Well, here's what it is. It's the log of that base, 1.01875, and then it's of 3.6, and that's going to equal 4t. Okay, so again, to solve for exponents, we're going to use logs. So I'm just going to hit the math key. Here's my math key. And again, this is all bonus here. So if you want to just get the answer and skip this part of the video, that's fine. But well, I'll teach you this later. So I'm going to insert that base. Okay, so here's my base. I just put it right here, so I didn't want to recopy it. So I pasted that base in for the base, and then I need to do 3.6. It's going to tell me 689549557. I'm just going to write the whole thing, equals 4t. And then our last move to get our answer is to divide by 4. Okay, and so here's where we want to round to 3 decimal places. So I'm going to round that 8 to a 9. So it's going to take 17.239 years for your money to go from 5,000 to 18,000 given these conditions. Okay, so again, that's where we're heading. We're going to be able to solve for an unknown exponent by using logs. Okay, so that's going to be in a couple sections from after you take your quiz. So this, between the 2 parts, this should be enough practice. You have more practice in your notes. So just check the notes. I have the complete notes in Schoology. So the ones that we didn't do together in class, you can try, compare your answers. If you need help, just ask. Okay, so thanks for watching. This should be a quiz that everyone does well on. Watch and learn and practice. Okay, take care.